Okay, so this is going to be a continuation of our examples using the quadratic formula to solve a quadratic equation. So remember in the previous part of this, we indicated that any quadratic equation, no matter what your quadratic equation is, all quadratic equations can be solved using the quadratic formula. Now you are asked to simplify the solution. So that means simplify any radicals that exist if possible, and then simplify fractions. Now let's remind ourselves real quick, what a quadratic formula looks like, or what the quadratic formula looks like. And so recall that in the previous part we talked about the quadratic formula, quadratic equation being ax squared plus bx plus c equals 0. We said that was in standard form. Okay, so this is standard form, so you have all the terms on one side, 0 on the other. And remember, a, b, and c can be any real number. So the coefficients, even the constant term can be any real number as long as a is not 0. Because then if a is 0, you would no longer have a quadratic equation, you would have linear. And then the quadratic formula is this. So remember to read it this way. You're going to read it as the opposite of b plus or minus the square root of b squared minus 4ac. And see this radicand? Remember the radicand is the part that's under the square root symbol or the radical symbol. So this radicand is called the discriminant. You're going to learn more about discriminants in another lesson. And all of this is being divided by 2 times a. Okay? All right, so let's quickly look at some examples. So this is going to be number 1. So number 1, we have x squared minus 5x equal, so x squared minus 5x equal x plus 4. Okay? All right, now first of all, is this in standard form? It's not in standard form, right? So I'm going to bring all the terms on one side. So if I bring all the terms on one side, so I'm going to skip some steps here, but basically to bring the x over, we're going to subtract x from both sides. So the y'all are going to get x squared minus 5x, and when I subtract x from both sides, I get minus x. And when I subtract 4 from both sides, I get minus 4, and that's going to equal 0. So remember what's happening here. So you got to remember how to use your properties of equality. So you're subtracting x just like this, right? So when you combine like terms, this becomes 0. So that's where you see this part here is this. And then the next thing I'm going to do is subtract 4 from both sides. And so that's 0 here. So this part here is this. Now let's combine like terms. So when I combine like terms, I get x squared, a negative 5x and a negative x is a negative 6x, minus 4 equals 0. All right, now once you get it in standard form, that's standard form. Once you get in standard form, you have to denote a, b, and c. So remember, a is a coefficient of x squared. So remember, a is a coefficient of x squared, b is the coefficient of x, and c is your constant. So a, the coefficient of x squared is 1. So a is 1. B is a coefficient of x. That's negative 6. So don't make a mistake and say 6, because that's a negative 6. So even though you're saying subtracting 6x, remember subtraction you can write as an addition problem. So that's really x squared plus a negative 6x. So the coefficient of x is negative. And then c is your constant, which is a negative 4. And so now you're going to substitute into the formula. And so your variable is x. So you're going to say x equal. And remember, it says the opposite of b. The opposite of b. So b is a negative 6. The opposite of a negative 6 is a positive 6. Plus or minus the square root of. Now remember, when you write your radicand, which remember is a discriminant, in this quadratic formula, it's called the discriminant, the radicand, put that in parentheses. So you're saying negative 6 squared. Because if you don't put in parentheses, your calculator is going to give you the wrong number here. And a negative number times itself should always be positive. So this should be a positive number always. Or 0. So b squared should be positive or 0 because b can be 0. Minus 4 times a is 1. And notice the parentheses I'm putting. Times c, which is negative 4. Again, notice the parentheses. Now remember, you've got to simplify the radicand, but first of all that's being divided by 2 times 1. And a is 1. So you got to make sure you write this just like this. Don't leave out any steps, because directions will say show all work. And it must be logical, it must be mathematically correct. So don't leave out any steps. Do it just like this. Okay, now, when we simplified the radicand, remember the order of operations, so I'm squaring and I'm multiplying, I'm subtracting, right? Or adding. If you want to think of this as subtracting, as adding the opposite. Okay, but remember, in order of operations, you always do the exponent first. So negative 6 squared is a positive 36. So this becomes 6 plus or minus the square root of 36. Now a negative times a positive times a negative is a positive. 4 times 1 times 4 is 16. All divided by 2. So simplifying the radicand, I get 6 plus or minus the square root of 36 plus 16, using your calculator, 36 plus 16 will give me 52. All divided by 2. Now remember, the direction says to simplify. Remember, it says say simplify solutions. So simplifying the radicals, simplifying the fractions, whatever you need to do. Now be careful. Don't simplify the 6 into 2 and say that's 3 plus the square root of 52. That's not true. All right, because remember, 2 is being divided into 6, and it's also being divided into the square root of 52. So you got to be careful. Don't reduce this part first. You got to simplify this first. All right, so let's think about the square root of 52. Is there a perfect square other than 1 that goes into 52? And always use the largest if possible. What I would do is I would use the next larger number, the next larger perfect square, which is 4. So let's see if 52 is divided by 4, divisible by 4. And it is, because 13 times 4 is 52. And then 13 is a prime number, so the only perfect square that goes into 13 is 1. So I can't simplify the 13 any further. So the square root of 52 becomes the square root of 4 times the square root of 13. And the square root of 4 is 2, so this is 2 square root of 13. So that's what this becomes. So you have to do that. If it says simplify, you must do this. So this becomes 6 plus or minus 2 square root of 13, all divided by 2. Now you can simplify, you can reduce. So 6, 2, and 2, all of these are all divisible by 2. So if you think about it, I'm going to go ahead and rewrite this. If you think about this, you're saying 6 divided by 2 is 3, 2 divided by 2 is 1, 2 divided by 2 is 1. So this becomes this now. 3 plus or minus 1 square root of 13 is square root of 13, and then divide by 1, which means this. So there's your answer. Now, so remember, you in the previous lesson, if you go back to the previous lesson, we were talking about the discriminant. See how the discriminant is a positive number, but it's not a perfect square? So that means you're going to end up with 2 irrational solutions. So basically, whenever you're left with the square root in your answer, it's going to be, you're going to get irrational. As long as it's not, let me rephrase that, as long as you don't have an imaginary number. All right, so there, if you don't see, if you're not taking the square root of a negative number, then it's going to be irrational if you still have a square root symbol. All right, now on my math lab, they're going to ask you to write 2 separate solutions. So you can say 3 plus the square root of 13, and then 3 minus the square root of 13. All right, so that was number 1. Okay, let's look at number 2. So number 2, we have this in number 2. We have all right, we have, let's say, we have 3x minus 1 times 2x plus 3 equal 5x. So 3x minus 1 times 2x plus 3 equal 5x. Now, don't make the mistake. A common mistake people make is whenever they see this thing in factor form, they want to use, remember the zero factor property? So what they want to say is they're going to say each of these equal to this. But remember, that only applies if this is what number? The zero factor property only applies if that's 0. That's not 0. So you cannot say, do not say this equals 5x and this equals 5x. All right, the only time that applies is if this is 0. All right, so what you have to do here, is you got to FOIL this out. So you see how you have those 2 binomials? So let's FOIL. So 3x times 2x is 6x squared. The outer is 9x. The inner is a negative 2x. And the last, negative 1 times 3, is a negative 3, equal 5x. Now let's combine like terms first. It's not in standard form. You must put it in standard form. But before we do that, let's combine these two like terms. So this becomes 6x squared plus 7x minus 3 equal 5x. All right, now to put in standard form, we subtract 5x on both sides. And so then I get this. I get 6x squared plus 2x minus 3 equal 0, because 5x minus 5x is 0. All right, so now it's in standard form, so I can determine a, which is 6, the coefficient of x squared, b, which is the coefficient of x, so b is 2, and c is your constant, which is negative 3. And so using the quadratic formula, my variable is x, I'm going to say x equal the opposite of b, so that's a negative 2, plus or minus the square root of b, no parentheses, you must use parentheses, b squared minus 4 times a is 6, times c, which is negative 3. All of that is being divided by 2 times a, which is 6. So simplifying the radicand, remember you got to do the exponent first and then multiplication. So I'm going to get negative 2 plus or minus the square root of 2 times itself is 4. A negative times a positive times a negative is a positive. So I'm going to say 4 plus. So I'm going to be adding these two terms here. 4 times 6 times 3, so 24 times 3, that's going to give me 72. Okay? All divided by 12. Okay? All divided by 12. So 4 plus 72, you got to simplify the radicand. 4 plus 72 is 76. So that's negative 2. Plus or minus the square root of 76, all divided by 12. All right, so that's where I'm at. Now, just like in our previous discussion, don't reduce this and say this. I need you to understand that this is not true, that this right here is not true that I'm about to write. Some students are going to reduce negative 2 and 12. They're both divisible by 2, and so they're going to say this is going to be negative 1 plus or minus the square root of 76 divided by 6, and that's not true, okay? So don't make that mistake. So be careful. All right, what you need to do is simplify the square root of 76 first. If we can simplify this. So let's talk about the square root of 76. So is there a perfect square other than one that goes into 76? Let's see if 4 will go to 76. So 76 divided by 4 gives me 19, and 19 is a prime number. So yes, so 19 times 4 is 76, and I cannot simplify the square root of 19. So this becomes the square root of 4 times the square root of 19. That's 19, square root of 19. So that's the square root of 4 is 2, so that's 2 square root of 19. Okay? All right, now that is this. So let's rewrite this part here with this. That's what you got to do next. So that's going to equal negative 2 plus or minus 2 square root of 19 divided by 12. All right, now before I go on and simplify this, reduce, remember how the discriminant is a positive number and it's not a perfect square? And so basically meaning that you're going to still have a square root in your answer. So my question to you is this. Are these going to be rational or irrational? It's going to be irrational. So you're going to get 2 irrational solutions. 2 irrational solutions. All right, now don't leave it like this because you do need to see that I can reduce the negative 2, the 2, and the 12. So they're all divisible by 2. So if you think about it, let me go ahead and rewrite this. If you think about what I'm saying, is this. Negative 2 divided by 2 is a negative 1. 2 divided by 2 is 1. 12 divided by 2 is 6. So I get negative 1 plus or minus. Now don't put 1 square root of 19 because 1 square root of 19 is just square root of 19. So just write it like that. All divided by 6. And so that's your solution. And if you want to, you can write it as 2 separate solutions. In MyMathLab, you will need to do that. So you're going to say negative 1 plus the square root of 19 all divided by 6, comma, negative 1 minus the square root of 19 all divided by 6. Okay? All right, so that was number 2. Let's look at number 3. So let's suppose in number 3, I had this. And number 3. So number 3, I have x squared plus 6x plus 13 equal 0. So x squared plus 6x plus 13 equal 0. Okay, so it's already in standard form. A is going to be 1. That's a coefficient of x squared. B is a coefficient of x. That's a positive 6. And C is your constant. So that's 13. And so if I substitute all these values into the quadratic formula, I get x equal the opposite of b. So that's the opposite of 6 is a negative 6. That goes here. Plus or minus the square root of b in parentheses, 6 squared, minus 4 times a is 1, times c, which is 13. All of that makes you to say all of that is being divided by 2 times a, which is 1. A is 1. So this becomes negative 6 plus or minus the square root of, so I'm simplifying the radicand, which remember is called the discriminant. 6 times itself is 36. A negative 4 times 1 times 13, so that's going to be what, 52? Okay, so that's minus 52 though, right? All divided by 2. And then 36, simplifying that, the radicand, the discriminant, 36 minus 52, will give me a negative 16. All right, now here's the question I want to ask you before we go on. Are my solutions going to be real or non-real? They're going to be non-real because you cannot take the square root of a negative number and get a real number. Okay, so you will have 2 non-real solutions. All right, so we're going to talk more about that in the next lesson. We'll talk about discriminant. But I do need for you to simplify the square root of negative 16. So you all know the square root of a negative 16 is 4i. Okay, so this becomes 4i. So I get negative 6 plus or minus 4i, all divided by 2. All right, now, so don't leave your answers like this because remember the direction said simplify your solution. So I simplified the radical, and I'm going to simplify my fractions. And so all of these are divisible by 2. So do y'all agree that, and I'm going to go ahead and write it right here, do y'all agree that all of these are divisible by 2? So negative 6 divided by 2 is a negative 3. 4 divided by 2 is 2, and 2 divided by 2 is 1. So I get, now remember the denominator is 1. So what that means is that this just becomes negative 3 plus or minus 2i. So that's what that becomes. So that's the solutions. So that's your 2 solutions. So you get two imaginary solutions. 2 imaginary solutions. And so you can write them in compact form or you can separate them. So if I separate them, I'm going to get negative 3 plus 2i and then negative 3 minus 2i. Now notice that those are conjugates, right? So if you recall from our previous lesson, we looked at complex numbers in a previous lesson. So you notice that these are conjugates, negative 3 plus 2i and negative 3 minus 2i. You're going to learn in the next lesson that whenever an imaginary number is a solution, its conjugate will also be a solution as long as these are real numbers. Okay. All right. So notice those are conjugates. So I want to make you aware of that. All right. So that was number 3. Let's do number 4. So number 4. Let's suppose we have, number 4, we have this. We have 1/5 x squared plus 1/3 x minus 1/3 equals 0. Now don't let the fact that you have fractions here throw you off. Don't do that. You learned in a previous lesson when we talked about linear equations and rational equations, that you can clear your fractions. So let's clear these fractions. Remember, you multiply both sides by the LCD. So what's the LCD here? The LCD is 15. All right, so let's multiply both sides by 15. So you're going to say 1/5 x squared plus 1/3 x minus 1/3. All that is being multiplied by 15. And remember, what you do one side, you have to do to the other. All right, so if I distribute, so that should look familiar. You did that in a previous lesson where you had to multiply both sides by the LCD. So when I distribute, I get 15 times 1/5 x squared plus 15 times 1/3 x minus 15 times 1/3 equal, and then 15 times 0 is 0. Now let's reduce. So when I reduce, 5 into 5 is 1, 5 into 15 is 3, so I get 3 times 1x squared, which is 3x squared. Plus, and over here, 3 into 3 is 1, 3 into 15 is 5, so that becomes plus 5 times x is 5x. And then here, that's 1, that's 5, and so I get 5 times 1 is 5, so this becomes subtract 5, equals 0. Okay? So now it looks a lot better, doesn't it? So just beware if you have fractions. If you have fractions, just go ahead and multiply by the LCD, and it makes it an easier problem to deal with. Do not use fractions in the quadratic formula. You're going to have a very difficult time simplifying whatever you end up with. All right, so don't say A is 1/5. Don't say B is 1/3. Don't say C is negative 1/3. You will have a very difficult time using the quadratic formula. So do this and then say A is 3, B is 5, and C is negative 5. So notice it makes things a lot easier for you if A, B, and C are integers. So notice in all the problems we've done, if you go back to all the problems we've done with the quadratic formula, A, B, and C were integers. All right? Okay. Now, so let's go ahead and use the quadratic formula. So I get x equal the opposite of 5, so that's negative 5, plus or minus the square root of 5 in parentheses squared minus 4 times A is 3, times C, which is negative 5. All of that's being divided by 2 times A, which is 3, equal negative 5 plus or minus the square root of, now I'm going to simplify the radicand, the discriminant. 5 times itself is 25. All right, a negative 4 times 3 times a negative 5 will be a positive. Negative times a positive times a negative. And that's going to be, let's see, 12 times 5. So that's what, 60? All divided by 6. Okay? And so then I get negative 5 plus or minus the square root of 85, all divided by 6. That's where I'm at. Now let's see if I can simplify the square root of 85. So that's a little harder to deal with, but let's use 5. I know 5 is not a perfect square, but I want to see if what I end up with will be divisible by a perfect square. So I'm going to use 5, even though 5 is not a perfect square, because I do know that 85 is divisible by 5. I get 17. Now the question is, see how you have 5 times 17 is 85? Besides 1, well, is there a perfect square that goes in a 5 or 17? The answer is no. So that means that I cannot simplify the square root of 85, so there's your answer. There's your answer. Now on my math lab, you're going to write it as negative 5 plus the square root of 85 divided by 6, comma, negative 5 minus the square root of 85 divided by 6. And you can also, if you want to, you can write it as two separate fractions. So in other words, you can write it as negative 5, 6 plus the square root of 85 divided by 6, comma, negative 5, 6 minus the square root of 85 divided by 6. So different ways of writing the answer, as long as it's correct. Okay? All right, so just wanted you to notice that you cannot simplify the square root of 85, so you have to leave the square root of 85. And so before we go on, so you see how square root of 85, the discriminant was positive and it's not a perfect square? So that means you're going to end up with some real solutions, but what kind of real solutions are they? Are they rational or irrational? They're irrational. So you get two irrational solutions. So that's what you end up with. All right, let's do one more with this, and let's see. let's look at this one. So this will be number 5. All right, number 5. Okay, so in number 5, you have 3y squared plus 9y plus 8 equal y squared plus y plus 3. All right. So you'll notice that this is not in standard form, so we got to put this in standard form. And so some of you know that when you bring terms to the side, the sign changes. Some of you may need to do this, and I'm about to do this. Okay, so you may say, well, to get this y squared to the other side, I'm going to have to subtract y squared from both sides. Subtract y squared, just like this. And then I would need to subtract y as well, right? Just like that. And then I would have to subtract 3 as well, correct? All right. So I did a bunch of things in one little part, which is not always a good idea. It does confuse some students sometimes. But I subtracted y squared from both sides. I subtracted y from both sides. And then I subtracted 3 from both sides. I'm just aligning my like terms. Now I'm going to combine like terms. 3y squared and a negative y squared is a positive 2y squared. A positive 9y and a negative y is a positive 8y. 8 and a negative 3 is a positive 5, equal, don't forget your equal sign. And notice all of this is 0, right? When you combine like terms. So basically what you have on the side is 0. So now it's in standard form. So now A is 2, B is the coefficient of y, which is 8, and C is your constant, which is 5. And so you're going to get, if you substitute into the quadratic formula, now remember your variable now is y, so you got to say y equal the opposite of 8, so that's negative 8, plus or minus the square root of b, which is 8 squared, minus 4 times a, which is 2, times c, which is 5. All of that is being divided by 2 times a, and a is 2. Okay? Now let's simplify the discriminant, the radicand. And so 8 squared is 64. So negative 8 plus or minus the square root of 64. A negative times a positive says times a positive is a negative. And so 4 times 2 times 5. So what's that? That's 10 times 4 is 40. Is that correct? All divided by 4. 64 minus 40 is 24. So I get negative 8 plus or minus the square root of 24. All divided by 4. All right, now before I go on, am I going to get real solutions or non-real? Are they real or not real? They're real, right? Because I'm taking the square root of a positive number. But this radicand is not a perfect square. So that means there are going to be 2 irrational solutions. That's what that means. 2 irrational solutions is not a perfect square. Okay, now let's simplify the square root of 24. There is a perfect square that goes into 24 other than 1, and that is 4. So I get the square root of 4 times the square root of 6. So that's 2 square root of 6. So that goes here. So it becomes negative 8 plus or minus 2 square root of 6, all divided by 4. Now don't leave your answer like this because you can simplify what you see. The negative 8, 2, and 4 are all divisible by 2. So if I do that, so I'm going to go ahead and rewrite this over. So when I reduce, negative 8 divided by 2 is a negative 4, 2 divided by 2 is 1, and 4 divided by 2 is 2. So this right here becomes negative 4 plus or minus. Now don't say 1 square root of 6, just leave it at square root of 6. All right, square root of 6. That's the way we prefer to write it. All divided by 2. All right, and there's your answer. Do not make the mistake. Don't make the mistake. This is a mistake that students make, just to make you aware of that. See this right here? For some reason, some students want to do this. They want to reduce this. And so they want to say the answer is negative 2 plus or minus square root of 6. That's not true. Okay, not true. Because if you split this apart, because remember, there are different ways you can write this answer, correct? So you can write 2 separate fractions now. So in other words, you can write this as negative 4 divided by 2 plus or minus the square root of 6 divided by 2. Now negative 4 divided by 2 is negative 2 plus or minus the square root of 6 divided by 2. You can't simplify that, so that's all you can do. notice is this right here the same as this? It's not. All right, so you got to be careful. Don't reduce incorrectly. That's reducing incorrectly. So be careful. Be careful. All right. Now, in my math lab, they're going to want to separate these into two separate solutions. So you can use this one or this one. Does not matter. Okay, does not matter. So in my math lab, just to make you aware, you can use this one. So you'd say -4 plus the square root of 6 divided by 2, comma, -4 minus the square root of 6 divided by 2. Or you can use these two separated, or you can say -2 plus the square root of 6 divided by 2, comma, -2 minus the square root of 6 divided by 2. All right. Now, one of the mistakes people make, this is another mistake they want to make. You see this square root of 6 divided by 2? That is not the square root of 3. So don't say 2 to 2 is 1, 2 to 6 is 3, because that's not a 6. That's not 6. 6 divided by 2 is 3. That's true. That's not true, okay? Because the square root of 6 is not 3. The square root of 6 is, if you put that into your calculator, the square root of 6 is approximately equal to about 2.45. Okay, that's what it's approximately equal to. So you see, that's not the same thing as 6. So be careful. If you're not careful with what we just talked about, there are easy errors you can make. All right, so be careful. You don't want to lose any points just because you were not thinking very carefully. All right, and so let's actually do one more. Let's do one more. So sometimes in your problem, you may see something like this. So let me just kind of mention this. Okay, so let's do this will be number 6. So I just want you to be aware of something you may see as well. So remember when we talked about A, B, and C, we said A, B, and C can be any real number. Now, when we looked at those, when we did them, in almost all our problems, A, B, and C were integers, which is a real number. And we did a problem where A, B, and C were fractions. So basically being rational numbers. But we cleared the fractions. So we ended up having integers, right? So the idea is this: whenever using quadratic formula, unless they tell you to use a calculator, notice nowhere in here did it say use a calculator. You have to show the work. Unless they tell you to use a calculator, you want to make sure that A, B, and C are integers. So A was 1/5. That's not an integer. B is 1/3. That's not an integer. C is -1/3. That's not an integer. So that's why I multiply both sides by the LCD, was to get these to be integers. Okay? So when we look at number 6, here's what I'm going to, well, first of all, let me write down number 6. So here's number 6. 0.2x squared minus 1.2x plus 0.8 equal 0. Sorry, right here. So 0.2x squared plus minus 1.2x plus 0.8 equals 0. Now, A, B, and C are real numbers. They are real numbers, but are they integers? So you see, if you want to use the quadratic formula to make things easy on yourself, you need to make sure that A, B, and C are integers. Those are not integers. All right, so what we got to do is somehow get those to be integers. That's what we need to do. Now, one way to do that is, see when I read this, I read this as this is really 2/10. 2/10, right? Okay, so let's think about this. That's 2/10. Y'all agree? All right. When I read this, y'all agree that's -1 and 2/10? Y'all agree? Plus, and y'all agree that's 8/10? Oops. So if you look at this, what is the least common denominator? Well, that's 10, correct? That's 10. So what I'm going to do is this. Since when I read this is 2/10, this is 1 and 2/10, and this is 8/10, I am going to multiply both sides by 10. Multiply both sides by 10. And the reason is that when you do that, it's going to make these numbers right here, these coefficients and this constant, and sometimes it's called a constant coefficient, a integer. All right, so we multiply both sides by 10. So I'm going to go ahead and rewrite this over. 0.2x squared minus 1.2x plus 0.8 equal 0. So I'm going to say times 10 times 10. What I do to one side, I do to the other. Now when I distribute, use your calculator with that part. Well, actually, when you multiply by 10, y'all remember that when you multiply by 10, the decimal point moves one place to the right. So what's 10 times 2 tenths? Well, 10 times 2 tenths is 2. So that's 2x squared. What's 10 times 1 2 tenths? Well, that's 12. So it becomes minus 12x. And then 10 times 0.8, or 10 times 8 tenths, is 8. Equals 0, because 0 times 10 is 0. So now it's in standard form, and notice A is an integer, B is an integer, and C, which is a constant, is also an integer. So see, it makes things a lot easier for you. Now you just use your quadratic formula. So we're going to get x equal the opposite of b. So the opposite of negative 12 is a positive 12. Plus or minus the square root of b in parentheses. Because remember, if you don't put in parentheses, it's going to be negative. And remember, b squared should always be positive or 0. B squared should never, ever be negative. Minus 4 times a, which is 2, times c, which is 8. All of that is being divided by 2 times 2, which is 4. And let's simplify the discriminant. Now remember, whenever you have a radical, the part that's under the radical is called the radicand. But in a quadratic formula, that's actually called the discriminant. You're going to see that in the next lesson. So I get 12 plus or minus the square root of negative 12 times itself is 144. So b squared should always be positive or 0. That should never be negative. The next term can be negative, but b squared should always be positive or 0, never negative. A negative times a positive is negative. So I'm adding a negative number. 8 times 8 is 64. All of that's being divided by 4. So I get 12 plus or minus the square root of 144 minus 64. Use your calculator if you need to. You're going to get, 144 minus 64. You get 80. All that's being divided by 4. All right, now, before we go on, am I going to get real solutions, 2 real solutions, or am I going to get none real? Well, I can take the square root of 80, so there's going to be real. Now, since 80 is not a perfect square, it's positive, not a perfect square, it will be 2 irrational solutions. Sum it up with 2 irrational solutions. Now, let's go further. Let's simplify the square root of 80. So let's see if 80 divisible by 4, because 4 is a perfect square. So 80 divided by 4, I'm using my calculator, and I get 20. But you need to ask yourself, can 20, is there another perfect square that goes into 20 besides 1? Yes, because then 4 go to 20 as well. So this 20 that I'm pointing to is really 4 times 5, right? And that 4 times that 4 is 16. So what's the largest perfect square that goes into 80? It is 16. So 80 divided by 16 gives me 5. So the square root of 16 times the square root of 5. And the square root of 16 is 4. So this becomes 4 square root of 5. And that goes here. So this becomes 12 plus or minus 4 square root of 5, all divided by 4. And here's what I want to ask you. Is this how you want to leave your answer? The answer is no. Because you know you can simplify 12, 4, and 4. So all of these are all divisible by 4. Okay, don't say 2. They're all divisible by 4. Okay, always use the largest one. And so let me go off to the side. So basically this is what you have. So you're going to say 12 divided by 4 is 3. 4 divided by 4 is 1. 4 divided by 4 is 1. And since the denominator is 1, you're just going to get this numerator. So the answer is going to be 3 plus or minus the square root of 5. Don't say 1 square root of 5. Just write it square root of 5 over 1, which is this. And then if you split it apart on the math lab, you can write it as 3 plus the square root of 5, 3 minus the square root of 5. Okay? All right, so for that one, just remember that whenever we use quadratic formula, A, B, and C were integers. In this problem, A, B, and C were not integers. So we had to multiply both sides by 10 because 10, multiplying this by 10, multiplying this by 10, multiplying this by 10 makes those coefficients now integers. All right, and now it makes things a lot easier for us. Okay, so that will be the end of that lesson.